Today's lesson is on graphing proportional relationships. And when we're graphing proportional relationships, we kind of talked about this already. There's certain characteristics about each graph that have to be true in order for the relationship to be actually proportional. Remember, a proportional relationship is always changing by the same amount. You're always increasing by the same amount or decreasing by the same amount. But regardless, it's always the same. So that has some effect on the characteristics of our graph. So let's look at this top part here in our notes. When a proportional relationship is graphed, it will always form a straight line and it will always pass through the origin of the graph. So straight line through the origin, 0, 0. If those two things happen, then it will be a proportional relationship. So to add some vocabulary words, proportional relationships are linear. Linear means straight line. And will pass through the origin. So linear going through the origin represents a proportional graph. Here's an example here. Mark is filling his pool with water. The table below shows the average number of water or gallons that fill the pool in a given number of minutes. We're going to use two ordered pairs to create a proportion to show that this is a proportional relationship. Doesn't matter which we choose or which order, so I'm just going to go ahead and look at 1 and 12 and 2 and 4, or 2 and 24. So if I set up a proportion, 1 over 12 equals 2 over 24, a couple of things I can do. I can use my mental math method. 1 times 2 is 2, and 12 times 2 is also 24. Since these multipliers are both the same, I know that these fractions are equivalent, which means that they are proportion. On the flip side, I could flip them around, do 24 over 2 and 12 over 1. Use my cross products test. 1 times 24 is 24. 2 times 24 is also 24. Because my cross products are equal, these are proportional. So the table shows a proportional relationship. All right, what is the constant of proportionality? Constant of proportionality, that is the big fancy word for unit rate. Remember, when we're finding that constant of proportionality, we're always taking our y value divided by x. So even though minutes is represented with m because it's in the top portion, that would be my x. The bottom part would be my y. So I'm just going to take any value. It doesn't matter. So because we haven't done this one, let's do 36 divided by 3. 36 divided by 3 gives me 12. But that really makes absolutely no sense unless I tie my units with it. So if I look back at 36, it was in the gallons of water category. So it's going to be 36 gallons in 3 minutes. My unit rate would be 12 gallons per minute. And what that means is that 12 gallons of water fills the pool every 1 minute. 12 big milk gallons of water fills the pool every minute. Part C, we're going to write an equation to show the relationship between the minutes passed and the gallons filled. This will help us here if we look at our constant multiplier. We're always multiplying our m value by 12 to get our g value. In other words, we're taking 12 times m to equal g. So we find our gallons of water, by taking 12, which is our unit rate, times the minutes that have passed. Okay, let's take a look at graphing. Remember, when we are graphing and we're taking information from the table, we're going to take our x value to our y value. So x, comma, y. And just reading those points off of the graph or off of the table here, it would be 0, 0, 1, 12, 2, 24, 3, 36, 4, 48, and 5, 60. Graph is already labeled for us. Let's get to plotting. So 0, 0 is here, 1, 12, 2, 24, 3, 36, 4, 48, and then 5, 60 isn't on the graph, so we don't have to graph it. But if you'll notice, all of these points form a straight line and they go through the origin. We're going to go ahead on part D and graph the data. And we're going to mark the constant of proportionality with a star. In part B, we identified the constant of proportionality as 12 gallons per minute. And we broke it apart by saying 12 gallons for every 1 minute. This part right here in the table, 12 gallons for every 1 minute, or this ordered pair right here represents our unit rate. That means on the graph, this one's our star. We're going to write that down, 1, R, or 1, 12. In a proportional relationship, this 1, R point, whenever my x value is 1 in my ordered pair, whatever number follows it is my constant of proportionality or my unit rate. So in this case, it'd be 1, 12, where 12 is my constant of proportionality. Finally, part E is asking us, does the graph show a proportional relationship? We call that direct variation. And how do we know? Give 2 pieces of evidence. First of all, yes, because it's a straight line, meaning it changes at the same rate. And it goes through the origin. Example 2 is asking us to look at the cost of buying mathlete shirts to wear to the competition. In our table, we have the number of shirts and our X position on the table, and then total cost on the Y spot. So here for A, we're going to use any 2 ordered pairs to create a proportion to show that it is a proportional relationship. Doesn't matter which ones you use, as long as you don't really use the 0, 0, that kind of makes it tricky. But I'm going to use 2 over 11 and 4 over 22. First of all, I could simplify 4 22nds and I would get 2 11ths. Or I can rock out my cross products. 2 times 22 is 44. 4 times 11 is 44. Since those are equivalent, that shows that my relationship is proportional. Part B is asking us to identify the constant of proportionality. And then the last example, we kind of talked about how you can find the constant of proportionality by looking for when your X value is 1. So I want to know the total cost per 1 shirt. On this table, I'm not really given that, so I have to do a little bit of math. Remember, we can always find it by taking Y divided by X. Y divided by X, any Y divided by X. I'm going to go ahead and use $55 for 10 T-shirts and figure that out, because I know when I divide by 10, I can move the decimal to the left 1 place. And that means if I put my labels to it, it would be $5.50 per shirt. That's my unit cost. And C is asking us to form that relationship, that equation to show the relationship. My unit cost, or that constant of proportionality, is my constant multiplier. It's always when I'm multiplying. So if I take 10 times 5.5, I would get $55. 8 times 5.5, or $5.50 for each shirt, I would get $44. I'd get the total cost. Basically what I'm doing is I'm taking whatever my X value is, or my shirts, and they want us to use S, and I'm taking it times 5.5 to get the price, P. So price equals 5.5 S. D is asking us to graph the data. We can go ahead and pull all those ordered pairs, 0, 0, 2, 11, 4, 22, 6, 33, 8, 44, 10, 55, and then graph them. 0, 0 is on there. 2, 11, which would be about here, I think. 4, 22, 6, 33, 8, 44, and then 10, 55. All those points fall in a straight line that go through the origin, and we're going to mark the constant of proportionality, which we found to be 55, or $5.50. So if you were to work this table, kind of looking at it, you're going up by 2 shirts and up by $11. So if I'm going to go from 2 to 1, I'm going to divide by 2, and then I'd also divide by 2 here, which confirms that 11 divided by 2 would be 5.5. That ordered pair then would be 1, 5.5, which matches up with our 1, R, where wherever our X, when our ordered pair, the X value is a 1, that means our unit rate will be the next number, because it costs $5.50 for 1 shirt. We're always wanting to know the cost for 1. And that means that my unit rate will be right about there, where X is 1. It's asking E, does the cost of the shirts vary directly with the number of shirts purchased? Yes. We have a straight line. Through origin. You could also say that every shirt costs $5.50, and all those ratios would simplify. You're not charged any sort of screen printing fee or design fee. It's just straight up the cost per shirt. So because there's no hidden fees and it's always the same amount per shirt, this is a proportional relationship. Example 3 is asking us to look at these graphs and determine whether or not they're proportional. If they're proportional, we've got to give that constant of proportionality. We can find that easily by looking for when X is equal to 1, we go up to Y and find out what that value is. All right, graph 1. First of all, we need to have it being a straight line through the origin. If I connect those dots, I notice it's a straight line, but it does not go through the origin, so this is not proportional. If I connect the dots in graph 2, it goes through the origin, but it's not a straight line, so the answer is no. Graph 3, connect those dots. It is a straight line, and it does go through the origin. So I'm going to go over here, and I'm going to read the graph. I'm going to go to 1, and then I'm going to go up to that Y value, which is 20. So my constant of proportionality would be 20 students reading my Y label, per 1 week, reading that X label. Okay, next up, graph 4, connect those dots. I have a straight line going through the origin. Now, if I read my graph, I'm going to 1 for X, but I really don't know any information here. It would be all a guess. I'm looking for points that fall on grids. So if I look at this 5, 10, I know that this is X and Y. I can still do my Y divided by X, to be 10 divided by 2, or 10 divided by 5, which gives me 2 pages, looking at my Y value, per 1 week, looking at my X label. Okay, that about does it.